Welcome back to Software Architecture course, Module 4. In this module, we dive into basic architectural styles and patterns. We have 3 lessons. First lesson about monolithic architecture. This is strengths and weaknesses. Monolithic architecture is one of the simplest and most widely used architectural styles. Lesson 2, layered architecture. A layered architecture, also known as n-tier architecture, organizes a software system into distinct layers, each with specific responsibilities. In third lesson, client-server architecture. This is one of the widely used style and its applications. Client-server architecture is a foundational software design paradigm where the system is divided into two primary entities, clients and servers. Monolithic architecture is one of the simplest and most widely used architectural styles. In a monolithic system, all components such as user interface, business logic, and database interactions are tightly integrated into a single executable deployable unit. The strengths of monolithic architectures are simplicity in development and deployment. Monolithic systems can be simple and straightforward to develop because all components reside in a single code base. Performance benefits is one of the strengths. Communication between components happen within the same process, making it faster than inter-process communication in distributed systems. And with all components being in one place, end-to-end testing is less complicated compared to other styles such as distributed architecture. Fewer resources are needed for managing and maintaining monolithic application, making them suitable for small teams or startups. And it has its own weaknesses as well. Scalability challenges. Monolithic systems scale vertically by adding resources to a single server, which is limited and costly compared to horizontal scaling, adding more servers in distributed systems. Any change to one component often requires rebuilding and redeploying the entire system, leading to slower development cycle. As the code base grows, it becomes harder to manage, and developers may encounter spaghetti code where dependencies between components are unclear. And technology choices are constrained because all components must use the same technology stack, even if some components could benefit from different tools. A failure in one part of the system can bring down the entire application, as all components are interconnected in these architectural styles. When to use monolithic architecture? When the system is small or mid-size, projects with well-defined and stable requirements, or a startup or a small team that needs to move quickly without complexity of a distributed system. And next, layered architecture. The structure of layered architectures are like this. There is a presentation layer which handles the user interface and user interactions. And there is an application or business logic layer which manages the system's core business logic or workflows. Then there is a data access layer, provides access to database or external data sources, and data store layer or database layer where data is stored and retrieved from the persistent storage. The strengths of this architecture is like this: separation of concerns. Each layer focuses on a specific role, making the system easier to understand, develop, and test. Layers can be developed, updated, and replaced independently without affecting other layers. Logic in one layer can be reused across multiple applications, such as a shared data access layer that can be reused. Changes in one layer, example, database updates, can, can have minimal impact on others. It has its own weaknesses as well. Performance overhead, communication between layers adds latency, especially in systems with heavy data processing. Enforcing strict boundaries can limit flexibility, especially for rapid evolving systems. For small projects, the overhead of managing multiple layers may outweigh the benefits. And when do we use a layered architecture? Application with clear boundaries between responsibilities, systems with requirements for scalability and maintainability, and teams with developers specializing in specific layers. In this lesson, the client-server architecture is a foundational software design paradigm where system is divided into two primary entities, clients and servers. This architecture is widely used in web application, mobile apps, and distributed systems. How this architecture works. There's a client and there is a server. The client is the user-facing part of the system, responsible for sending requests to the server and presenting responses to the user. Examples are web browsers, mobile apps, desktop softwares. And the server processes client's request, performs operations. Examples are data retrieval and computation, and returns responses. The examples are web servers like Apache, and there are other servers like database servers. The strengths of this architecture is centralized control. Servers are centralized and data and logics are in the centralized server, simplifying updates and security management. Also scalable, multiple clients can interact with single server, making it easier to scale horizontally by adding more servers. And resource sharing. Clients access shared resources such as databases through the server. It also has its own weaknesses. If the server goes down, clients lose access to the system. No clients would work. Servers can become bottleneck under heavy traffic if not designed to scale effectively. Communication over networks introduces latency, especially in geographically distributed systems. Applications of these architectures are web applications where the browsers, they are also clients, interact with web servers to fetch and display content. Email systems, client like Outlook or Gmail connect to email servers. Banking application, for example, where users access accounts and perform transaction via client apps communicating with secure servers.